Hello and welcome to our lesson on solving trig equations. We're going to go back to our definition of solve we always use. In this case, we need to find all values of theta that make both of these expressions true. Alright, so let's have a look at question 2. And it's going to give us some steps to work our way through this. So first thing we need to do is find the reference angle. Remember, the sine of the reference angle is the same as the absolute value of the sine of the angle. So I'm going to use alpha to represent my reference angle. So I'll have sine alpha equals the absolute value of -1/2, which means that sine alpha will equal 1/2, which means alpha is going to equal 30 degrees. Okay, and we could get that 30 degrees either from our special triangle or from our calculator. Obviously, in this case, calculator is easier. Okay, step 2, we're going to draw a diagram with our reference angle in all possible quadrants. In this case, sine is going to be negative. So we're going to do all students take calculus, which means that sine is negative here and here. So that's going to be 30-degree reference angle there, and a 30-degree reference angle there. Okay, and I'm just going to do step 3 here just to keep everything on the same page. So let's call this our first angle. So notice our first angle, we're going to have 180 degrees to there, and then plus another 30. So our first angle is going to be 180 degrees plus 30 degrees equals 210 degrees. And our second angle is going to be a full 360, but then minus 30 off of that. So angle 2 is going to be 360 minus 30 degrees is going to give us 330 degrees. Okay, and same as usual, we can check our solutions. So we think that 210 and 330 are going to make both of those expressions true. Obviously, 210 and 330 are between 0 and 360, so they make the second expression true. And we can just use our calculators to verify that the sine of 210 is in fact negative 0.5. And we can also fire the sine of 330 into our calculators, and that will also give us negative 0.5. Okay, and we're going to use the same 3 steps to do question 3. So first we need our reference angle. So cos of alpha is going to equal the absolute value of 3/4, which we can use our calculators to figure out that alpha equals approximately 41 degrees. All students take calculus. So our 2 possible terminal arms are going to be there and there. Reference angle of 41 there, reference angle of 41 there. Obviously our first possibility is just that theta is 41 degrees. Our second possibility is that it's 360 minus 41 degrees, which gives us 319 degrees. Okay, so there's our 2 possible solutions. And let's just use the calculator to verify those. So if I go cos of 41 degrees, that's going to give me 0.7547, which, because we approximated it to 41 degrees, that's a close enough check to 3/4, which is of course 0.75. And let's fire the cosine of 319 degrees into our calculator, and again we get the same thing. Oops. Should be 47. Okay, so it doesn't come out exact, but we knew we rounded the 41, so that's close enough for our check. Okay, question 4 we're going to have to approach slightly differently. We've got tan theta equals 0, which I guess in one way we could think of it as, if we do tan alpha equals the absolute value of 0, which is of course 0, we'd get alpha equals 0 degrees. The other way to think about it is tan theta is always y over x. So the only way tan theta could be 0 is if y equals 0. So if y equals 0, there's two possible places our terminal arms could be, there or there. Okay. Notice those are also the two places where our reference angle would be 0. So however you look at it, we're going to end up with our angle theta is either going to be 0 degrees or 180 degrees to make that true. And again, quick fire that into our calculators. Do the tan of 0 degrees, we're going to get 0. And if we do the tan of 180 degrees, we're also going to get 0. And here's our last example. Obviously, this one's from the textbook. So they tell us that tan alpha, and here's, this drives me nuts. So let's change all of these alphas to thetas, because we've gotten used to using theta as our angle in standard position and alpha as our reference angle. So I think there's more at the bottom of the page here as well. So let's change all of those to thetas. And there's going to be some questions in the assignment as well, where they're going to ask you for angle alpha in standard position. It's just going to save you a lot of headaches and confusion if you just change those to thetas. Okay, so we've got our tan theta equals 5 over 12, and we need to find the exact value of the other primary trig ratio. So that means sine and cosine, basically, they want to know. Okay, so let's have a look here. So there's two sets of answers. Oops, that's not a very nice line. So if we go, all students take calculus, we can see that one possible place our terminal arm could be here. The other one is facing the other direction towards the t. Let's just look at this one for now and see what we know. So tan is 5 over 12, which means that y is going to be 5 and x is going to be 12. Notice this isn't to scale, but it's not a big deal. And we have a right triangle there with that is 5 and that is 12. So we can use Pythagoras to figure out our radius. So we're going to end up with r squared. That's not a very good r. R squared equals 5 squared plus 12 squared. So we're going to get r squared equals 169. Square root both sides. Square root of r squared is the absolute value of r. It's going to equal 13. So r is going to equal positive or negative 13. And of course it's not going to be negative. So we just end up with r is 13. Oops. So there's our radius there on our diagram is 13. Okay. And now we've got sine theta, which is y over r. So that's going to be 5 over 13. And cos theta is x over r. So that's going to be 12 over 13. Okay, so that's our first possibility from the first quadrant, is that sine theta equals 5 over 13 and cos theta equals 12 over 13. Okay, our second possibility is down here in the third quadrant. We'll still have tan as positive, and that means this is going to be at negative 12. That's going to be at negative 5, and this is still going to be 13 long. So sine theta equals y over r, so that's going to be negative 5 over 13, and cos theta equals x over r, so that's going to be negative 12 over 13. Notice we can also see from our all students take calculus that only tan is positive in this quadrant, So sine and cosine would both be negative. Okay, and now part B is exactly the same stuff we've done on the previous pages. So the first thing we need to figure out is our reference angle. So we're going to have tan of alpha as our reference angle equals the absolute value of 5 over 12, which means that alpha is going to equal approximately 23 degrees. Which means that that's going to be 23 degrees, or that's going to be 23 degrees. So our first possibility is that theta is going to be 23 degrees from quadrant 1, or it's going to equal 180 plus 23 degrees, which gives us 203 degrees. So there are our two possible solutions. And if I fire this into the calculator, we get tan of 23 degrees equals 0.4245. And tan of 203 degrees equals the same thing, 0.4245. And we can compare that with 5 over 12 punched into the calculator, which is 0.416 repeater. So obviously we've got some pretty significant rounding errors, but within those rounding errors, that's definitely close enough.